Today I'm going to talk about mobile site and native app accessibility. And I want to start off with some mobile accessibility. Oh, what's that? Mobile accessibility fails. So back in 2014, I actually had this presentation that I ran everywhere about the mobile accessibility fails that we were seeing and how they couldn't necessarily fall into WCAG, but I'm going to talk about some of the ones that do fall into WCAG here. So this is an example of Jamie Oliver's recipes, and this is a fail of WCAG 2 success criterion 2.2.2 pause, stop, hide, because as soon as you open the mobile app, a video plays, and it was back then really difficult to actually pause the video if you're a screen reader user. We have here fail of WCAG 2 success criterion 1.4.3 contrast minimum. This is the Amazon site, and excuse me, the search bar, what are you looking for, is actually grey text on a white background and really difficult to see. And so I actually spoke to a UX person who worked in one of these organisations, Amazon, eBay, Alibaba, one of those, and they said that they changed the placeholding characters to meet colour contrast requirements, and their profit margins increased by 13%, which is really impressive. Excuse me a second. Sorry about that. This here is a error of WCAG 2 success criterion 3.3.1 error identification and 3.3.3 error suggestion. So I used to, before COVID, do a lot of traveling, and I don't think I would have been able to do it as easily if I didn't have access to Netflix. But occasionally I'll get this error, which is called error. And it has no other information, and it just has a cancel button. So what is the error? Is the error that I don't have internet access, that I don't have access where I am, is my username and password incorrect, etc. And this here is a failure of WCAG 2 success criterion 1.4.4 resize text. So on the left, you've got the very, very smallest text that you could do. And on the right, you've got the very, very largest text that you could do. And there's actually, the small text is very small, but the large text is not particularly large. And the biggest problem with this is that if you actually scroll up to the top of the article, you find that whether you ask for small text or large text, you actually get exactly the same visual representation. So the small text and large text is not inherited by the article title, the information, the date, the time, the caption, the author, etc. And then this here fails 3.2.3 consistent navigation. Before we got onto Trello, we used Asana, and I would operate always off my tasks. If something wasn't on my tasks, then I wouldn't do it. But if you looked at the mobile app, there was no my tasks. So I found the mobile app basically useless. And so we moved to Trello. Sorry about the coughing. So why did we develop this methodology? So we found that there are a whole bunch of accessibility issues that didn't fall under WCAG 2. And so I went around and I spoke about what some of these things were. And we had a conversation at the ICT Accessibility Testing Symposium, which is in its third or fourth year now. And it was decided that it would be a good idea if some accessibility specialists got together and actually wrote a mobile site and native app testing methodology. Just one moment. I'm just going to, I think I might have a bit of asthma, so just one moment. Sorry, hopefully that has sorted it. So basically what happened is I was co-chair of a committee in 2018, and we developed one set of guidelines that covered both mobile sites and native apps. And then the following year we formed two separate subcommittees, which I was co-chair of both, one specifically for mobile sites and one specifically for native apps. And while we were doing the mobile guidelines, WCAG 2.1 was released. And so we were really hoping that WCAG 2.1 would address the issues and that it would make our work obsolete. But unfortunately, that was not the case. So for example, pointer gestures, so ensuring that the size of an actionable item is large enough to tap on is a AAA requirement in WCAG 2.1, even though that's a very well-known accessibility requirement when it comes to mobile. WCAG 2, just in case you weren't aware, WCAG 2 definitely had some problems when it came to mobile. So for example, WCAG 2 required that everything be accessible via the keyboard, but it didn't require that everything be accessible via touch or via mouse. So that's one of the reasons that we had to have 2.1. And 2.1 definitely did add some mobile accessibility requirements around pointer gestures and geolocation and things like that, but it really wasn't enough. So why is mobile different? Mobile is different because firstly, there are native screen readers that are inbuilt into the system, TalkBack in Android, and of course there's Voice Assistant in Samsung, Narrator in Windows Phone, if anyone has a Windows Phone anymore, should be like, you know, up on your wall as, you know, an artifact, and VoiceOver on iOS. Then there's levels of volume control, haptic keyboard, visual, auditory, and further vibrational notifications, text-to-speech and speech recognition, Zoom, there's grayscale, there's a whole bunch of different things. So there's also things like increasing font size, touch and hold delay, screen rotation, high contrast, assistive touch, and mono audio. And there are a huge array of system settings that people can use for accessibility requirements. And they differ to desktop because most of the time with desktop, you have a whole array of different applications that you could use, like Zoom text or something like that. Whereas with mobile, you're restricted to what is input into the device. Another thing that 2.1 made very clear was page variations. Low vision users who use the zoom function inherent in the browser are often restricted to a mobile view of the site of their desktop if they're looking at a responsive site. So if you zoom at 200%, then often that triggers the mobile version of the site. So as part of WCAG 2, 200% should already be included in regular testing. But you need to make sure that you aren't removing functionality if you are showing the mobile version of the page. So it's important that your functionality is available on all variations of the page. So an example of this is YouTube, and this has been fixed. The upload and notifications button were visible at 100%, but not at 200%. And so people viewing at 200% wouldn't be able to access the upload or notifications button. So this is the example that I'm talking about. Upload and notifications are up in your top right next to your profile, and they're visible at 100%. And at 200%, they're gone. And so if you're using the Zoom function on desktop, then you actually have triggered the mobile site, and the upload and notifications aren't available on the mobile site because they assume that if you're going to do uploading, you're going to use the mobile app. So there's also accessibility supported under 2.1, which means that you need to, and especially with native apps, test assistive technology such as TalkBack, VoiceOver, switch control, etc. And this does apply to WCAG 2, but it's made much clearer in 2.1. Let's talk about the methodology. It's important to note that this methodology does not require, does not include the errors in WCAG 2. So, for example, this methodology doesn't include that your images must have alt attributes, because that's covered in WCAG 2. We are looking at expanding the methodology to include that information, but at the moment we're talking about the things that you have to do in addition to 2.1. So the kind of testing that you'll need to do for a mobile site is test your desktop site against WCAG 2, test your mobile site or against WCAG 2, or your native app against WCAG 2, and then test the methodology as well. And if you take one thing from this presentation, take that you should always test with real devices. So as I said, I used to do a lot of travel. I'm not quite sure what my life is going to look like in this post-COVID world, or this current COVID world. And back when I first started traveling a lot to the United States, there was no Wi-Fi on planes. And so if you've ever flown to Australia, it's a 14.5-hour flight. It's a very long time to be without internet. And often because, you know, traveling, flying that long, you can't really be guaranteed of how, you know, long it will take to land, etc. We'd often sit on the tarmac in LA for an hour or two before a gate was available. So we'd get into LA, get into the tarmac on LA, and I'd be able to access the airport Wi-Fi, which was just fantastic. And so this is the screen I got, which is, you know, logging into the Wi-Fi, and I've logged in, and it says this page will redirect. So content doesn't really make sense to have here. And all of a sudden, I don't feel safe giving you my credit card details. So be aware that you must test with real devices. And if they're geo-locked, then you need to test in actual locations, not spoofed locations. You really need to test the way that your users are going to use your systems. For mobile sites, there are 4 main testing methods. The first is, of course, to test on devices. The next is to test with devices with assistive technology or system features. The third is to test in a responsive window. So there is some testing that you can do on desktop in a responsive window, so it's easier to access the code, for example, when you're testing like that. And you do also need to test on desktop in a fully functional desktop website, because you need to compare what's on the desktop site to the mobile site. On native app, there's only 2 testing methods: testing on devices and testing with devices with assistive technologies. So I'm going to talk a little bit about site types, and of course this applies to mobile sites only. Excuse me a moment. So there are 3 types of mobile sites. There's a desktop website, which have only one display, whether it's viewed on a desktop or a mobile or tablet device. Then there's M.dot sites that have a particular display for mobile and tablet sites. Now, the M.dot site is a completely different site to your desktop, to what you're seeing on www. So you need to test M.dot on the desktop and against WCAG 2, as well as the www site against WCAG 2 and mobile. And then responsive is where this content changes depending on the screen size or other feature. So this is an example of a desktop site. This is the Australian National Botanic Gardens. So you can see you've got your left-hand navigation, header, your main content. And if you make that smaller, or you view it on a mobile a mobile device, you actually see just a cut-down version of the page. Nothing changes. You can do this by dragging the browser window narrower and seeing what changes, or you can do it by viewing it on your mobile device. The second is the M.dot site. Now, there are 3 things that you should do to identify an M.dot site. Ask the client, but often they don't know. Change the URL to have it start with an M instead of a www. and do that on your desktop and do it on your mobile device as well. And then also compare the site on a desktop to the same site on a mobile device. And when I run a mobile testing workshop where we go into the guidelines in a lot more detail, and I ran it at Stanford about a year ago now, and we found that there was an MDOT site in Stanford that the 25 or so people at Stanford that were at this workshop didn't know about, and they were all from IT. So, it is important to undertake these 3 steps because the client doesn't always know. So this is an example desktop site. So we've got a www.sephora, and if you look at it, if you replace the www with MDOT, you get something that looks very different. So I'll compare the two again. So that's the www, and that's the M. And then if you make the screen smaller on both, you can see on the left, the desktop doesn't resize at all, and the MDOT does. So that would be 2 separate sites that you need to test against both WCAG 2 and the mobile guidelines. And don't think that just because something's a www site that it won't be used on mobile. One of the requirements is that you need to be able to move between the www site and the MDOT site and vice versa, whether you're on mobile or desktop. And there will be people that will access the desktop on mobile, which is why it needs to be tested. And then, of course, we've got responsive websites. Now, most of the sites that you look at will be responsive. If it is responsive, it's definitely not a desktop site. However, it is possible there's still an MDOT site. So to identify a responsive site, basically the site will change, the layout changes as you change the browser window. So the best way to test this is open the website in a browser, ensure the window is not maximized, select the right-hand edge and drag it to the center of the screen. So this is an example of the Accessibility Oz site. On desktop size, you've got your top navigation along the top, and you've got one row of 6 items for services. If we make that smaller, then the navigation turns into a hamburger menu, and the services are 2 by 2 instead of 6 by 1. I'm just going to talk very briefly about variations of a page, which is also on About Mobile site only. You must test each variation of the page and against WCAG 2 and the mobile guidelines, and all functionality must be available on all variations of the page. Now, you can hide the functionality, so behind a expandable menu or on a different page or something like that, but you must have all functionality on all variations. Why do people provide variations of a page? Often it's to highlight particular content on mobile, such as phone details, or hide particular content on mobile, such as image galleries, and that would be a violation of these mobile guidelines. And there's also, of course, hiding functionality that doesn't work on mobile, such as a drag and drop. And in that case, you need to provide alternative functionality that has the equivalent functionality. There's 4 main triggers for variations of a page. So device, so basically the code can determine what device is showing the site and serve content depending on that. So that way you'll get different content if you're looking at on a desktop versus a mobile. It can also determine the operating system or the browser. But the most common way of triggers for variations of a page is screen size. That's probably accounts for 95% of all variations in responsive sites. So I talked a bit about this before, where you have the navigation on Accessibility Oz horizontally and then replaced by a hamburger menu. Now, it's really important that these are 2 separate pieces of code, and therefore they both need to be tested on the desktop as well as on mobile, or against WCAG 2 and against the mobile guidelines. So they are 2 distinct pieces of code. So you must test both. Whereas if you've got something like this, you got a variation just in the presentation where you've got the ICT Accessibility Testing Symposium, you've got Home Committee Register Program horizontally across the page, and then when you resize it, they turn vertical. So you only need to test one of these for colour contrast requirements, for example, and one of these for keyboard focus indicators and things like that, because the code is the same. It's only the layout that's changed. And as I mentioned before, each variation of a page needs to be tested. Talking about native apps, we discussed a lot about native apps and how we should really look at testing, and we decided that we needed to look at specific elements within native apps that needed testing. So the first thing you need to do when you're looking at a native app is define application functionality. So you need to know the purpose of the native app and what functionality is critical to its purpose and use, and look at it from a workflow perspective, because on a website, you can often get to, say, any of the 1,000 pages through a myriad of ways. But often in a native app, you can only get to a page or a screen through one way. So, you know, that changes how you do testing. And so, for example, if you're looking at a banking mobile app, then it's really important that the login process works, that you can transfer money, that you can do the two-factor authentication, etc., etc. Whereas if you're looking at a bank mobile site, then you're looking at a whole range of different things, like whether the map works, whether the store locator works, etc. So that often there's much more limited functionality in native apps, and that should be reflected in how you do the testing. So, sorry, I shouldn't say iPad, but basically the things that you should really focus on are things like navigation, menus, headers, footers, landing pages, emergency alert pages, login pages, settings, accounts and profile, contact us, real-time updates like eBay and Uber, you know, your car is approaching, privacy policy, terms and conditions, interactional, transactional, things like selecting a product, adding to a cart, payment, live chat, help, Q&A, widgets, calendars and date pickers, third-party integrations like geolocational maps and etc., and also high traffic areas. And in terms of what you should then do is ask the question, how would the experience be impacted if this functionality failed or this content couldn't be reached? You know, if that happens, will that mean that the user can't use the native app? And then, of course, everything within your native app needs to be accessible. However, it's important to define your critical functionality and ensure that that is prioritised in your testing. So let's talk about the actual methodology. So there's one major difference between the mobile site methodology and the native app, and that is step 2. But so there are 5 steps. Step 1 for a mobile site is identify devices. Step 2 is identify site type and variations. Step 3 is test critical issues. Step 4 is test mobile specific issues. And step 5 is test mobile assistive technology and feature support. For the native app testing methodology, step 1 is identify devices. Step 2 is define application functionality. Step 3 is test critical issues. Step 4 is test mobile specific issues. And step 5 is test mobile assistive technology and feature support. So let's devices. For the mobile site, you're looking at recommended devices of iPhone, Safari, iPad, Safari, and Android phone and Chrome. And it is important to note that you should use Chrome instead of, if you're using a Samsung device, the Internet native app, because Chrome is a much better representation of how the site will appear across a multitude of Android devices, not just the Samsung phones. The other thing you should consider is an Android tablet, such as the Samsung Tab A or a Chromebook, and alternative devices such as a Kindle device if you're testing, say, a book or something like that. We recommend that you test on the latest version of iOS and on the latest 2 versions of Android. And if a site is directly aimed at people with a particular kind of disability, consider including assistive devices or assistive technologies used by those users. So if the site is aimed at Switch users, then you should really be testing with switches. And as I said before, you need to meet WCAG 2 and this mobile methodology. So for the mobile site, you need to identify site type and variations of the page. The first thing is identify if the site is desktop, responsive or MDOT. And then if the site is responsive, identify each variation of the page. And then you'll have a list of various different pages and variations that you need tested. For the native functionality, and we talked about this quite recently, the common elements that you must test, and then asking the question. And then testing critical issues, critical errors. Now, we identified a series of what we call traps in mobile sites and native apps. And we called them traps because we thought that they were the equivalent of the keyboard trap in WCAG 2, where a user, when they enter into an element, they can't escape that element if they're using the keyboard. So most often seen in things like video players. And so there are many more traps on mobile sites and native apps than on desktop. And we've spent quite a lot of time figuring out how to categorize these traps. So I'm going to go through them now. Exit trap. Ensure there is always an accessible, actionable item, e.g. a close button that meets color contrast requirements and has an accessible name that closes any feature that overlays the current page, such as a full page ad. This applies to all users, and the methodology is for both mobile site and native app. So this is an example of an exit trap. You're on a website, dailydot.com. However, you've accessed it through Facebook, so you're actually on a native app, and this is an ad for HP, and it basically overlays the entire page and there's no way to close it. This usually happens with an ad. This is another example. We're going to the San Francisco Chronicle. You've got a pop-up that talks about a fall sale, and you've got a little close button in the top right-hand corner that doesn't meet color contrast requirements. And so that is also defined as an exit trap. Then we have what we call a swipe scroll trap. Ensure you do not override standard mobile touch functions, swiping, scrolling, etc. on the majority of the page. This applies to touch users only, and the methodology is both mobile site and native app. So this is an example where when you scroll to the bottom of the screen, you can't then scroll up. The only way you can actually go back up the page is by activating that little arrow in the bottom right-hand corner, and that takes you to the top of the screen. This is an example that I've been using for, well, 6-7 years now. I'm sure it doesn't exist anymore, but I call it the Zoom of Doom. If you swipe anywhere in the map, which takes up most of the screen, then you move the map. And the only way to actually move the page is if you hit that small area of white that surrounds the map. Then we have what we call a text-to-speech trap. If the app has an ability to provide content via text-to-speech, the screen reader user must be able to pause or stop the app speaking in a simple manner, e.g. by performing a swipe on a screen. So this applies only to screen reader users, and the methodology is only native app because the browsers in the mobile devices have ways of stopping this. So this is an example here where once activated, this is Pocket, to press play, and I believe they fixed this. Once you've pressed play, the screen reader user can't actually stop the text-to-speech. So they'd have to wait till the article was finished before they could go, or close the native app and start again. Headset trap. Headset users must always be able to pause media, audio or video content by using the pause play control on the headset. And this applies to screen reader users and headset users, and the methodology is native app. So this is an example here where you're on a website and a video pops up in the bottom right-hand corner, and you have a little mute button in the right-hand corner of the video that, you know, is not keyboard accessible, but hey, and you can't actually pause the audio of that video using headset hardware. The pause on the headset pauses the screen reader. Then we have a layer trap. The user should not be trapped on a non-visible layer. This applies to all users, but it's mostly encountered by screen reader users, and the methodology is both mobile site and native app. And so this is an example here, where if you open the menu for this website, you actually are trapped on the page underlying the menu. So the menu opens on top of the current screen. You can see and you can interact with it via touch, but if you're a screen reader user, you're still reading the content underneath. Then we've got testing mobile specific issues. And I'll just go through a few of these, but the documents which detail all these things will be available on our website. And they're also on the ICT mobile site. So you're welcome, these documents are all available under Creative Commons. So you're welcome to use them and read them and use them to your heart's content. So the first group of issues are alternatives. So we require that alternatives are provided for non-web functionality that is mandatory. For example, recording a specific gesture by the camera before functionality appears. So, for example, this is a dating app called Bumble, and it's to prove that you're actually a person and not a bot. You have to copy the gesture in the photo, you know, take a photo and then submit it to prove that you're who you are. And it says at the very bottom, need another way, because obviously if you're vision impaired, you don't know what you're supposed to do. However, when you activate that, it has verification query, type your message. So it doesn't really tell you what it is that you need to do. And it's not, it definitely is very close to being accessible, but it's not perfect. Alternatives are provided for geolocation functionality that is mandatory, for example, requiring a specific geolocation before functionality appears, unless the geolocation is essential for legal reasons or doing so would invalidate the activity. This applies to geolocation via GPS, user statement, IP address, or other methods. So, for example, in this with IKEA in Australia, if you access the app and you've blocked your location, then you actually get this pop-up that says, info, location service is not enabled for this app. Please go to settings and enable it, limited functionality of app. This is a pass. So with the Lyft app, I was actually located in the Northeast Portland district, but I specified that my pickup would be somewhere where I was not located. So that's a way, that's a pass allowing you to basically bypass your current location. Another requirement is changes of state. So here we're talking about things like hamburger menus most of the time. So changes of state of non-standard controls are clearly indicated. So here in the top left-hand corner, when the hamburger menu on United is closed, you've got just a hamburger menu. And when the menu is open, that hamburger menu icon changes to an arrow that closes the menu. So it the state of the actionable item has changed visually, as well as in terms of the actual what it is read aloud by the screen reader. Then we have display, and there's a number of other requirements. I'm just going through some examples. So probably one of the most important requirements is size of touch targets is at least 44 by 44 CSS pixels, which is approximately millimeters. Which accords with the WCAG 2.1 target size. However, of course, that's AAA. And basically this is an example where it fails. You've got, you're going to the Airbnb site on your mobile and it pops up a would you like to install the Airbnb app, and the only way to close it is to hit a very small close button in the top left-hand corner, which is right next to the actual open the app, and it's very easy to open the app instead of closing that little overlay. This is an example of pass, so touch target size. You've got an Outlook message, your to section, your CC, BCC section, subject, they all are good target sizes in terms of this requirement. Another one is actionable items have sufficient inactive space between them. Inactive space of at least 10 pixels should be provided around active elements. And so this is an example here, Asana again, where in the top right-hand corner you've got, don't have a circle for it, you've got an edit button and then a mark complete button. And there's only about 5 pixels of space between the two. So it's really easy to hit the mark complete when you actually meant to hit edit. Then we have the actionable items section. Native UI controls, objects, alerts, and elements have been used. And so this is an example here where you have some weird widget drop down where instead of making it a select box, they've made it a text box with a drop down of 14, 15, 16, 17, but it also pulls up the keyboard. So you can't actually use the keyboard, but you can only select 4 of the numbers for the expiration date. When direct input via the keyboard is not required, provide options for the user to achieve the same result. I use a drop-down, radio buttons and checkboxes, etc. So this is an example here where you have to type in absolutely everything. So there's only 50 states in the United States. So that should be a drop-down. So it's not something that you should always have to type in. This is an example of something that passes this, where you've just written in 2001 M and you have a drop down here of all the different options that accord with what you've written. Functionality can be operated by device motion or user motion, can also be operated by user interface components, and responding to the motion can be disabled to prevent accidental actuation, except for certain situations. And this is similar to 2.5.4 motion actuation. So an example here is if you are using an iOS device and you shake it, you'll get an undo typing alert, which can be turned off on settings, but there's no alternatives, so that fails. The same happens with Facebook, where you can shake it and it says, do you want to report a problem? There is an alternative. You can do it through another means. However, there's no way to turn it off. Another issue here is infinite scrolling. Infinite scrolling we've deemed inaccessible according to the methodology. Navigational aids. Visual indicators such as arrows, next and previous buttons have been used to indicate swipe or scroll areas for additional functionality. So here, if you swipe horizontally from right to left, you actually go to the next section, which is My News. However, there's no indicator that swiping horizontally will do that. Navigational aids such as back buttons, breadcrumbs, next and previous buttons are provided. And so here, the way that you actually close this is by swiping from the top down to the bottom. However, there's no indicator that's what you need to do to actually escape from this page. Audio and video. We require that all audio and video have an accessible transcript, and this is an example where the text of the video and the explanation is below the video. Forms, we require that field labels are positioned adjacent to their input field and appear closest to their respective input field in relation to other field labels and other input fields. So this is an example here where you've got the yes radio button. It's actually slightly closer to the no field label than the yes field label. Then we talk about mobile desktop interaction, which of course is only mobile site. Item labeling between different types of a site and different variations of a responsive site is consistent. And so this is what I mentioned about Asana before, how my task is missing. And then you need mobile assistive technology and feature support. And you need to ensure that all actionable items can be accessed and activated by the following assistive technologies or the appropriate feature, and all important content can be accessed by the same. And we've got a list here of the mobile assistive technologies and features that we recommend. On iOS, it's VoiceOver, Keyboard and Switch, Zoom, Invert Colors, Grayscale, and Reader View. And in Android, it's TalkBack, Keyboard and Switch, Magnification, Invert Colors, Grayscale, Increased Text Size, and Simplified View.